Hello friends, this video on structure of atoms part 4 is brought to you by examfear.com. No more fear from exam. So as I told you that Rutherford model has limitation, and thus to one Bohr also gave a new model of atom which was better than Rutherford model. See, the Rutherford model looks okay because it was experimental. It was all explained using experimental data. The only flaw was the stability of the atom, right? So if, as per Rutherford model, this is the nucleus and these were electrons and they were just moving around here and there in any fashion, so it was expected that the electron will lose energy and fall down. So to overcome that, what Bohr did was, he told that he gave two postulates for this. First, he told that only spatial orbits called discrete orbits of electrons are allowed in an atom. So for a given atom, it will have only few discrete orbits, and all these orbits will have different energy. And while revolving in these discrete orbits, the electrons will not radiate any energy. That is what Bohr has postulated. Please note, he told that they are different orbits and each orbit will have different energy, and when the electrons are in this orbit, they will not radiate any energy. Why? He has not told. But he told that when electron moves from one orbit to another, it will radiate energy. So it could explain a lot of phenomenon. For example, when you the spectral of different metals, different elements, the spectra of hydrogen and other things which we'll understand in the higher classes. You take a hydrogen gas here and you pass a light through it, and then you'll see a different spectra of hydrogen. So these things we'll study in the later classes. Just understand that this Bohr model actually could explain a lot of stuffs, right? And the only extra thing it had over the Rutherford model was that the orbits are fixed for a given atom, and when the electron moves in a particular orbit, they don't radiate energy. Only when they move from one orbit to another, they emit energy or they take energy. So when it moves from higher orbit to lower energy orbit, it emits energy, and when you provide energy, then the electron from the lower energy will move to higher energy band, right? So but it had limitation. For example, it was especially for hydrogen. It could explain the spectra of hydrogen, but it could not explain the spectra of multi-electron atoms. So these points will not, it is not in the syllabus for you guys. If you don't understand, it's okay. You will have to understand this in the higher classes. Not required for now, but I'll just tell you that this was only for hydrogen, and it could explain the spectra of hydrogen, but not for multi-electron atoms. And in the Bohr model, he regarded electron as the charged particles, but the wave nature of electron actually ignored the Bohr's theory. And there were so many other concepts that came up, de Broglie concept, and then Heisenberg uncertainty principle, the Zeeman effect, Stark effect. All these effects could not be explained using Bohr theory. In fact, Schrödinger equation actually described the equation distribution in a space, and he actually the equation allowed the energy levels in atoms in a better way. So we'll understand these in the next class or higher class. Just understand this Bohr model was not perfect, and instead of Bohr model, the quantum model was proposed. In the quantum model also, it is not in the syllabus, but I'll just show you. As per quantum model, this is the nucleus, and you have electrons here, right? Electrons moves around like this. If you see, there is no fixed or circular path as explained in the Bohr theory. They move around in different orbits, you can say. Yeah, they move around something like this. We have different orbitals, 1s, 2s, 3s, and they move randomly, and this is the electron cloud. Actually, electron moves at a very high speed, and it moves at such a high speed that you actually can't tell the location of a electron with surety at a given point of time. They move at a very high speed. So it's quantum level actually. For quantum level, they also say that you can visualize atom as a wave, right? You just can't say that the atom is there. There's so many theories on this. We'll not go into this much because this is not in the syllabus. Just understand that this is the best model proposed till date. Right? The Bohr model is not very concrete. It had limitations, and this quantum model is the best model proposed till now. Talking about neutron, we told that 1932 this neutron was discovered very late in the game because it is neutral in charge, and well, nobody bothered about it. And it was Chadwick who discovered this neutron, and this it was seen that the mass of the neutron is nearly equal to the mass of proton. So mass of neutron, proton is almost equal, and electron is less. This is less. Neutron, proton is almost equal. Right? It was named neutron because it is neutral. And neutrons are present in all the atoms except hydrogen. Please note, hydrogen is the only atom which does not have neutron. Apart from that, all the atoms has neutron. It is represented by N. They just show you. N is the symbol of neutron, and the mass of the neutron is given by the sum of mass of proton. And the mass of the atom, the mass of atom is nothing but the mass of proton and neutron. Why? Because the mass of electron is almost negligible. So we ignore the mass of electron. The sum of mass of proton and neutron is mass of atoms. Mass of atom is mass of proton plus neutron. Okay, let's take some questions now. Name the three subatomic particles. Pretty easy. Electron, proton, neutron. This is electron and proton and neutron. Both will be inside nucleus. Thank you. Visit our website examfear.com to watch more and more quality education videos. You can also attempt free online tests that are there in our website. You can also get access to tons of free study materials, and you can also find free tutors and mentors in this website. Thanks a lot for watching.